So we're looking at exponential application. So on Friday we looked at problems like this one, where we say a scientist noticed that a population of bacteria doubled every hour. So again, I'm highlighting my doubled, which is what it's doing, so that's my growth rate. An hour is my interval. Again, I need to know that because they're going to ask me a question. So it says, if the initial sample was 150, what was the population after half a day? Okay, so this is kind of a review problem. When we look at this problem, okay, we start off, my initial value, I start with 150 bacteria, and it's doubling every hour. They want to know how much I'm going to have after half a day. Well, how many hours are there in half a day? Well, a day is 24 hours. Half of 24 is 12. So there are 12 hours in half a day. So at 0 hours, if I were to just fill out some points in this table, I had 150 little bacterias. Okay. After 1 hour, I can use my trusty calculator and see exactly how many I've got. I have 150 times 2 to the x power. When I look at the table, I can see how many I've got. After 1 hour, I have 300. After 2 hours, I have 600. And I could keep going, but what I really care about is what's after 12 hours, right? So after 12 hours, how many bacteria do I have? Oh my gosh, so many. 614,400. Okay? So I can look at the graph of this situation. It looks like that. Let's actually look at my values and kind of zoom out on them. Hang on a second. If I look at my window settings, my x's go from 0 to 12, and my y values go from 150. Let's just make it go from 0. Oopsie, I don't know what I just did. That's just crazy people stuff. Let's see, my y values go from 0 to 700,000. Now we look at the graph, and I can see what my graph looks like. So it kind of approximately looks like it stays real low, and then all of a sudden, whoosh, it goes up high. Okay, my asymptote, as we can see that this line here, it looks like it disappears, but that's just because it can't show it anymore. If I were looking here, I'd be able to see that line. And this is a huge jump, but what it's approaching is 0. So I know that my asymptote is y equals 0. So I could theoretically write my domain and range. Now, remember, for this one, what do we think this is going to be? Do we think it's going to be discrete or continuous? I think it's going to be discrete. I think it's going to be continuous data, because even though it's doubling every hour, they're dividing, well, this is a tricky one, honestly, but I know that my range is going to be greater than 0. I do know that. I think you could go either way on this one, depending on how you think about it. You could think about it as like, it's not like they sit there and all of a sudden, poof, in an hour, I've got twice as many as I had. But they're only going to double. So this is just a tricky one. It's just kind of hard to think about. Some of them are more difficult. Notice they didn't ask you about discrete and continuous or domain and range, so maybe I shouldn't have gone there either. We can talk more about this one when I get back if you'd like to. So just basically, just looking at what we sketched here, which one of these matches? It's blindingly obvious that this guy right here matches. We have growth, and this one here is decay. So this would be more like nuclear material that decays, like it has a half-life of 1 hour, which that's not good. So this would be something that was decaying. Okay? So that was the kind of examples that we did before. Now we're going to look at some ones that are more complicated. So in this problem, instead of saying that it doubled or tripled, it's saying it decreased at a rate of 5% per year. Okay? So what makes this a little bit more tricky is we have to think about how we're going to explain this, like how we're going to write our percent increase and percent decrease. So I'm going to kind of give you an example of this. Okay? Well, it's not. Well, let's try this gorilla one before I go into my pregnancy example if I have to, and if you guys want me to, I can tell you when I get back. So it says the western lowland gorilla is a critically endangered animal. In a certain location, its population is decreasing. So I'm going to highlight decreasing at a rate of 5% per year. if the population there is currently 900, about how long will it take for the population to drop to only 500 gorillas? Okay, so first thing I have to do is I have to figure out what my rate is, okay? So I know that I'm starting with 900, but I don't know what my rate's going to be, okay? So if my rate stayed completely still, like if I had no growth at all, then my growth rate would be 1. Because if it's bigger than 1, it's growing. If it's smaller than 1, like between 0 and 1, it's decaying. But if it's 1, it's staying still. So like if I gain 5%, 10% of my weight, if I stay 100% of where I'm at, I have not gained or lost any weight. Okay, so 1 is no growth at all. 1 means there's no growth at all. Okay? It means you're not growing or decaying. You're just staying even. Okay? So, if I were to write that as a percent, how do I write 1 as a percent? Well, 1 as a percent is 100%. Okay? So just take my word for it. If you are not growing or if you stay exactly where you are, you're at 100%. I know you're like, the grade book doesn't say that, Mrs. Deal, but 100% means you're not growing or decaying. Now it says I'm decreasing at a rate of 5%. So if I'm decreasing by 5%, what percent of gorillas will I have after that? Well, I will only have 95% as many gorillas as I did before. Okay? Now we don't do math on percents written as decimals. So I would write that as 0.95. Okay? So I can't put any percents into this little box here because I don't do math on anything that's not a percent. So what I'm going to put there is 100% minus 5%. Well, 100% is 1. 5% is 0.05. That is my rate of change. Okay, we're going to do some more examples of this, but let me walk you through that again. Okay, so when I look at this, I'm starting at, so if the population didn't change at all, I would have 100% of the gorillas that I had before. 100% of the gorillas. No change, no less, no more, exactly 900, 100% of those gorillas. But since it is decreasing at a rate of 5%, my 100% of my gorillas is decreasing by 5%, which means I'm going to have 95%. Okay? Now, I can't do math on things written in percent form, so 1 minus 0.05 equals 0.95. So I can actually write this in either of those ways. I can write 1 minus 0.05 to the x power, or I can write y equals 900 times 0.95 to the x power. I can write either one. Okay? So either one of those ways of writing it is acceptable. We're going to do more examples, so don't freak out. Okay? So if I put this into my calculator, so I'm going to put this one, 900, that's not what I put, 900 times 1 minus 0.05 to the x power, and I look at the table. All right. Did I put plus? I put 0.05 to the x. Okay, now if I look at the table, I start off with 900, then 855. It says, when will I have about 500 gorillas? Okay, well, it looks like I have over 500 at 11. So from like in 11 to 12 years, based on looking at this graph, in 11 to 12 years, I'll go, so in 11 years I'll have 500, and 12 years I'll go below 500. Okay, so like 11 and a half years or so, I'll have only 500 gorillas left in this western lowlands area. Okay, so let's look at another example. Okay, so this one, oh hey, look, that's the exact same thing we did there. So this is how they wrote it. Now, if instead of representing a percent decrease, I was representing a percent increase, what would I do instead? I would take my 100% and I would add 5% to it, which would give me 105%. So I would have 900 times 1 plus 0.05 to the x, and that would be an increase instead of a decrease. Okay? So I want you to take a look at these. I'm going to like legit pause for a while here and let you guys look these over. I want you to look at these and see which ones you think are growth and which ones you think are decay. Okay, 10 seconds is all I can give you, I'm sorry. So, let's take a look at these now. Okay, so if I look at this, if I'm subtracting, what am I doing? I'm decreasing, so this is decay. Okay, for this one, is it over 1 or less than 1? If it's bigger than 1, even that was just like we said before, if it was greater than 1, it was growth. So this one is growth. Okay, I'm adding, so that one's growth. That is actually a plus sign, and so that is growth. This is less than 1, so it's decay. Okay. Now, if I look at this one right here, this one is growth. Okay, it shows an increase of 6%. So I could write that also as 1100 times 1.06 to the x power. Okay? So these are two different ways I can write them. Now, I have to be able to go back and forth between them because if I write it one way and they show the answer the other way, I have to be used to it. If I write it like this and they're showing it to me as 1 plus 0.7, I have to be able to go back and forth between them. So let's take a look at them and let's write them really quick. I'll say, first of all, this one, what percent is 0.06? 0.06 is 6%, and it's an increase because I'm adding. If I want to write that in the other way, I'm going to write y equals 0.5 times 1.06 to the x. Okay? Because I might see this 6% increase, you know, starting with 0.5, increasing by 6% per whatever. I might see it written in either of these two ways, so I need to know how to go back and forth between them. Let's look at this one here. What do we have here? Do we have increase or decrease? Or we have growth or decay? Why do we have decay? Well, we have decay because this is less than 1. Okay, so that means I have how much less than 1? Well, it's 0.02 less than 1, which is 2%. So I have a 2% decrease. The other way I could write this is, since I know that decrease by 2%, I could say y equals 1100 times 1 minus 2%, written as a decimal to the x power. Okay? Let's try this one here. You guys give this one a try. You're going to tell me what percent it is, and then you're going to write it in the other form. So you're either going to, so if it's written like this, you're going to have to write it where it's using the plus or minus sign. Okay, so this one, I'm seeing an increase. I know it's increasing. I'm going to write it over here because I don't have a lot of room here. I know it's increasing by 7% because 1.07 is 107%. Okay, so the way I could write that instead is 180 times 1 plus 0.07 to the x power. And then this one, we have a decrease. I can see that because I'm subtracting, so it's going down 3%. So I would write that y equals 200 times 1 minus 0.03. And if you have to use your calculator, do it. 1 minus 0.03. Nope, that wasn't it. Is 0.97. So 0.97 to the x power. Okay? All of these, you need to be able to convert back and forth between all of these ways. Okay? So let's look at this last problem. We're going to do this one together. Okay, it says Marcel purchased a new truck for $26,000. Okay, so his start value was $26,000. The truck will lose value at a rate of about 10% per year. So we're going to say it's depreciating. And they call this depreciation. Appreciation is where something grows. Okay, so they have written this equation, which is an awesome equation. So if we want to figure out what this is, we could put this in y equals, but we can also just go to the home screen and write v equals 26,000 times 1 minus 0.10 to the 5 years. And if I do that, I have 26,000 times 1 minus 0.10 to the 5 years, which is 13,532, I'm sorry, 15,352, I said that all wrong, 0.74. That is his new value of his truck. Which, crazy, right? After he's only had it like 5 years, it's worth $11,000 less. Isn't that nuts? That's how cars work, people. It's no fun. You're going to do some practice on this. You're going to practice this in class, and then you have an assignment due before you leave, and then you're going to have another one for homework. If you have any questions, ask your partner. I will answer whatever questions I can when I get back. Feel free to shoot me an email if you are just hopelessly lost.